Hello and welcome to problem set number 6. Our topic today is chemical formulas for molecular compounds and acids. So we're going to get lots and lots of practice with writing formulas and names. All right, if you haven't already done so, I do highly recommend that you have this worksheet printed off from my website as you go through this with me. And let's get started. All right, problem number 1. We're going to name the following molecular compounds. Okay, so right away, you know it's a molecular compound. You know you're going to need those 10 prefixes to specify the quantity of each atom in the compound. Okay, so mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. All right, so PCl5. Converting that into the name, remember that we drop the mono prefix on the first element, so we're going to have phosphorus. And then for the chloride, there are 5 of them, so that's a pentachloride. All right, next, ICl7. So we've got 1 of the first element, iodine, so it's iodine, drop the mono, you don't write the mono on the first element, and then it's hepta for 7, heptachloride. Okay. Remember that you do still keep that IDE ending, even for a molecular compound. All right, going over to the second column here, we've got Ni3 and N2O4. So dropping the mono prefix, we just get nitrogen. And then it's tri for 3, triiodide. Keep the double vowel there. Triiodide. So keep the 2 I's. Usually when it's an A and an O or an O and O, remember we drop one of the vowels, but in this case we keep the double I's. All right, now we finally see one that doesn't have a 1 for the first element, so we're going to need the prefix now. It is dinitrogen and tetra for 4 and oxide. So we're putting an A and an O together, so we're going to drop the A and call it tetroxide. Okay. All right, going on to number 2. Now we're going to write the formulas for the following molecular compounds. We're given the name, we write the formula. This is, I think, much easier. So nitrogen dioxide must have just 1 nitrogen because of the lack of a prefix there. And the number of oxygen must be 2 because it's dioxide, and di means 2. Next is silicon tetrachloride. So again, a lack of a prefix for silicon tells you that there's only 1. Tetrachloride tells you that there are 4. So Cl4. Phosphorus triiodide, that means there's only 1 phosphorus. And there are 3. Tri is 3 iodides. All right, number 3. Now we're going to write the formula for the following acids. So sulfuric acid. Good thing to remember here. When you're missing the hydro prefix, you know automatically that you're talking about an oxyacid. Remember, all your binary acids start with hydro. That means they just have hydrogen and 1 other element. If it doesn't have the hydro prefix, you know right away you're talking about an oxyacid, which comes from your polyatomic ions. So in this case, we've got sulfuric acid. In fact, I'm going to write the name. And this comes from sulfate. I know it's from sulfate because the ic ending is always going to correspond to the polyatomic ion with the 8 ending. So not sulfite in this case, it's sulfate. So you really want to know your formula for sulfate, SO4 2-, commit those to memory, and then remember the charge is always going to tell you how many acidic hydrogen. So in this case, there are 2 acidic hydrogens, to balance out that 2 minus charge. Okay. And if you want to go ahead and write the aqueous state here, you can. All right, nitric acid. Let's do the same method here. Let's write it out because these are hard. I'm not going to sit here and pretend like this is easy. It's not. I remember learning this. I remember it being very hard. Okay, so nitric, that is from nitrate. I know it's nitrate and not nitrite because of the ic ending. Okay, so nitrate is NO3 with a 1 minus charge. Gotta memorize that. So we know there's just one acidic hydrogen. So this is HNO3. And I'll go ahead and write aqueous here. All right, acetic acid. Let's see if we have room to do that here. I think we do. Okay, this is from acetate, which is C2H3O2 with a 1 minus charge. So the formula for acetic acid is one acidic proton, so HC2H3O2. Remember, in the formula for an acid, only your acidic hydrogen is written first. So these 3 hydrogen are not acidic. Okay. And we'll talk more about the chemistry of acids in a further tutorial. A later tutorial. All right, let's erase all this. And let's go on to a number 4, where we are writing the full names for the following acids. So you're given the formula now, and you're writing the names. So I'll go ahead and write the formulas. Write them all out real quick. Okay. All right, so the first one is binary. It's just hydrogen and one other element. So it's going to be the hydro prefix. And then the stem of the element, it's iodine. So it's going to be iodic acid. Hydroiodic acid. The next one is an oxyacid. In fact, all of them are. They contain hydrogen, oxygen, and some other element. So really going to help out if you know those polyatomic ions. This is the nitrite. NO2 with a 1 minus charge. I'll write it in parentheses there. Okay, so nitrite becomes nitrous. Remember that if the ending is "ite," we change it to "us." If the ending is "ate," we change it to "ic." So in this case, this is nitrous acid. Okay. Next one, hopefully you recognize phosphate, which is PO4 with a 3 minus charge. Okay. So this becomes phosphoric. The ending is IC. Phosphoric acid. Okay. Last but not least here, we've got an oxyacid with carbonate as a polyatomic ion. So CO3 with a 2 minus charge. So carbonic acid with the 8 ending. Get the ic ending, so carbonic acid. Okay, let's erase all of this and go on to number 5. Write the formulas for the following ions, elements, or compounds. So this one's going to be a little bit tricky because I intentionally snuck in some ionic compounds there to make sure that you could tell the difference between a molecular and an ionic compound and therefore write their formula correctly. All right, let's start out with hydrobromic acid. Okay, so the hydro prefix hopefully tells you that it is a binary acid, and so it just has hydrogen and one other element, and the element you can get from the element stem, bromic acid, so it's a bromine. All right, tetrasulfur tetranitride, so 4 sulfurs for tetra and 4 nitrogen. Lithium carbonate. Okay, so here's where it gets tricky. Lithium carbonate, I hope you can recognize as an ionic compound. Okay, if you're not sure how, we're going to get it from the periodic table. Lithium is a metal. Carbonate is a polyatomic anion. So lithium carbonate is composed of metal cations and a polyatomic anion. So it is an ionic compound. So we need to check the charge on a lithium cation. It's in group 1A, so it's going to have a 1+ charge. Carbonate is one of the polyatomic anions that hopefully you are working on memorizing. So CO3 with a 2- charge. And so you can see that the ratio is going to be 2 lithium cations to every 1 carbonate anion. And you can also just use that little switch rule. 1 of these, 2 of these. So we're going to write it as Li, 2 of them, CO3, just 1 of them. So you don't need parentheses because you're not going to write a subscript for the number of carbonates. All right, let's go on to cesium ion. So cesium is a group 1A metal, which means that the charge is just going to be 1+. Oxygen, a little bit tricky here. Oxygen is one of your 7 diatomic molecules, so you want to write O with a subscript 2. Remember that the 7 diatomic molecules exist in nature in this diatomic form. All right, and last but not least, calcium sulfide. Okay, so calcium is a metal and sulfur is a nonmetal. So calcium cations combining with sulfide anions, that's an ionic compound. We got to check our charges. Calcium is in group 2A, so it's going to be a 2+ charge. Sulfur is in group 6A, so it's going to gain 2 electrons and obtain a 2- charge. So 2 to 2, which will simplify down to 1 to 1. So there's calcium sulfide. All right, there's 2 pages to this worksheet because I wanted to give you lots and lots of practice. So going on to the second page, last problem, number 6. Okay. Write names for the following compounds. Hint, it will help to first identify the substance as ionic, molecular, or an acid. Okay. So I'm going to go ahead and write these formulas down. All right, so now we can just go through and do them all. All right, so the first one, when you're faced with naming this, you need to know whether it's ionic or molecular. Okay, it's not an acid, it doesn't start with an acidic hydrogen. All right, so lithium is a metal, chlorine is a nonmetal. Metals and nonmetals combine to form ionic compounds. So here we don't need to use any of the prefixes. We're going to just name the cation by its element name, lithium, and then name the anion with the IDE ending. Okay, I think I'll do these in blue to make them stand out a little bit more. So from here on, I'll do them in blue. Okay, so the next one, we have a hydrogen at the beginning, and aqueous state. This is an oxyacid. Oxyacid because it contains hydrogen, oxygen, and one other element. So it's helpful to be able to recognize what polyatomic ion this comes from. It comes from the nitrite anion, which means that the name becomes nitrous acid. Okay. No hydro prefix because it's an oxyacid, not binary. And then based on the polyatomic ion nitrite, the ite ending becomes an us ending, and then add the word acid. Okay, Ki. Potassium is a metal. Iodine is a nonmetal. So we're talking about an ionic compound here. So name the cation by the element name, potassium. And now name the anion with the IDE ending, potassium iodide. All right, next, hopefully you recognize the ammonium polyatomic cation. And so that right away might give away that this is an ionic compound. So we know that this is a cation. We know that this is a polyatomic cation. So we're going to name this as ammonium chloride. Okay. And this one's probably pretty tricky because although this is a polyatomic cation, it is composed of nonmetals. So a lot of people might be tricked there by saying, well, this is nonmetals only. Shouldn't I name this as a molecular compound? So really the trick here is being able to recognize your polyatomic cation, which means that this is an ionic compound composed of cations and anions. All right, next we have phosphorus, which is a nonmetal, and chlorine, which is also a nonmetal. So this is a molecular compound, our first molecular compound. So we need the prefixes because remember, molecular compounds can have the atoms combining in a variety of different ways to make a variety of different compounds, and that's why we always have to have the prefixes in our names. So this is just one phosphorus, so drop the mono, so phosphorus. 3 chlorides, so trichloride. Okay. Now down here we have nitrogen and iodide, so let's check nonmetal with nonmetal. So this is another molecular compound. Drop the mono prefix for nitrogen, so it's just nitrogen. Always drop the mono prefix on the first element. The next element, iodine, so that's going to be iodide, and there's 3 of them, so it's going to be triiodide. Okay, remember that the double I, you keep both of them for your spelling rule. All right, K, that's potassium, that is an alkali metal. Carbonate, you might recognize right away as a polyatomic anion. I'll show you polyatomic ion. So this is clearly an ionic compound. So we're going to name it by the element name for the cation, potassium, and the polyatomic ion name is carbonate. Potassium carbonate. All right, going up to the second column here, we've got sodium, which is a metal, and we've got the polyatomic anion sulfite. So this is an ionic compound, so we're going to name it as sodium sulfite. Okay, trying to squeeze it in there because I want to keep my periodic table up. All right, so the next one is sodium, a metal, and sulfur is a non-metal. So we're talking about an ionic compound here. We've got sodium sulfide. A really common mistake I always see students making on the exam where they're doing these kinds of problems is that they're going to call this disodium monosulfide. Don't be the one to do that. This is an ionic compound. This is not a molecular compound. Name it by the ionic compound naming rules. No prefixes. All right, sodium, we already said in the last problem, it's a metal. Sulfate, you probably recognize as a polyatomic anion. So this is also ionic. So this becomes sodium sulfate. Okay. All right, next one, we've got barium, which is a metal in group 2A, and chlorine is a nonmetal in group 7A. So metals and nonmetals make ionic compounds, cations and anions. So we're going to call this barium chloride. Name the cation by the element name, and then the anion with the IDE ending. All right, carbon and oxygen. Carbon is a nonmetal, oxygen is a nonmetal. Another molecular compound, which means you need your prefixes. But we're going to drop the prefix on the first element because there's only one of them. So we're going to start with carbon. But don't drop the prefix on the second element no matter what it is. In this case, there's only one, so it is mono. Now remember, it's a double O, mono and oxide. We drop one of them and get monoxide. Okay, carbon and chlorine, both nonmetals. So again, we're going to need the prefixes. So you're going to drop the mono prefix on carbon, always drop the mono prefix on the first element of a molecular compound. And then the second element there are 4 of, so 4 tetrachloride. All right, last but not least, and then we will be done with this problem set. We've got aluminum, which is a metal, and sulfate, which is a polyatomic anion. So name it by the ionic compound naming rules, no prefixes. So no dialuminum here. Do not put dialuminum. Put aluminum sulfate. So undoubtedly there will always be students on this first exam where they're doing these kinds of problems who are going to write dialuminum trisulfate. Don't be the one to do that. Make sure that you're only reserving the use of those prefixes for your molecular compounds. You don't need them for your ionic compounds because the ratio of cations to anions is dictated by the charge. So they can only combine in one way. Okay, so you don't need the mono, the di, the tri prefixes for ionic compounds. You're never going to see aluminum sulfate in any other ratio other than 2 to 3. All right, that concludes our problem set number 6. Thank you very much for tuning in.